So hello and welcome to this Allegro Network Multimeter webcast. I'm Klaus Degner. I'm one of the founders and a managing director of Allegro Packets. And today I would like to present you our Allegro Network Multimeter. I named this session Networking and Troubleshooting with the Allegro Network Multimeter. We're a company headed in Leipzig, Germany, and we have 5 founders, and we do this now since over 4 years. We do all the development and research and support directly from Germany. What do we do? Well, we concentrate on network troubleshooting. Why? Today you have more and more cables in a network, physical but also virtual cables. And whenever you have a network issue, one service is not working, you can't debug the service alone. You need the big picture of the network, which means you sit in front of a lot of cables and you don't have time for troubleshooting, but you have to do it. So how can you look into a link, into a mirror port, into a PCAP file? So this is why we have developed the Allegro Network Multimeter, which gives you exactly this visibility. The idea is you have a portable solution, but also rack-mounted solutions. It creates visibility from layer 2 to layer 7. The access is extremely easy via a clear web interface. This is very important for us because especially if you have not used the device for 4 weeks, you can use it again because it's easy to use. We've concentrated on a high performance. This means that a 10 gigabit solution can do 10 gigabit, which is not so easy in troubleshooting, but also the gigabit solution can easily do gigabit. You have easy access to PCAPs and easy remote access. And there are many special networks which have 40 gig, 25 gig, or which need very high precision timestamps. We offer all these extension cards for these units. So which appliances do we have? As of now, we have as an entry-level appliance the Allegro 200, which can do gigabit traffic, and it's designed for branch offices, for smaller offices. We normally say up to 50 PCs or servers in a network, then it's good, this solution. We have customers who are using that with 3000 PCs. It's also fine. The limitation here is the in-memory database with only 2 gigabyte. The larger units, the Allegro 1000, can do up to 10 gigabit traffic throughput analytics. And the in-memory database is up to 128 gigabyte. Next generation, next internal generation can even do now 256 gigabyte of in-memory database. This is still a portable solution with the size of a book. It has 5 gigabit copper ports, 2 SFP Plus ports, and an extension slot for other network ports. The Allegro 1000 is also available as a high-end solution, which can do up to 40 gig processing speed. And now the new platform since October 2018 is the Allegro 3500 or 5500. Basically, that's a 4U server where you can add a lot of line cards and you can add a lot of in-memory database, but you can also add a lot of disks inside. To explain the difference between the in-memory database and the disks, I tell you we use 2 different databases in the system. Number 1 is the in-memory database. This stores all metadata and all statistics. Why do we do that? Only the in-memory database makes it possible to have immediate access to the data. Having this data on the disk, we have to aggregate a lot and we would lose a lot of information. By this method, we can have queries which need to process gigabytes of memory within milliseconds. On the other hand, we have a second database, which is a packet ring buffer, which is optional, so you don't have to use it, but you can. This stores the full link traffic or just a part of it. And a part can be splitted by MAC addresses, by slicing, so you just capture the first 64 bytes or you capture the first layers only. And it can be fully encrypted, so for data protection. But this is also available with a very large unit for up to 36 disks and can store easily 40 gigabit link traffic sustained. How can you install the Allegro? That's very simple. You can use it either inline or on a tab or on a packet broker or on a mirror port, but you can also process PCAPs from the past. Okay, so let me go back now to the web interface of the Allegro. And let me explain you a little bit how the web interface works. So you can access the Allegro via the integrated LAN interface or the integrated wireless access point. Both allow depending on the situation, very quick access to the web interface. For example, if you go to a branch office and there you need remote access, you don't have to ask for an IP address or so. You can just connect to the Wi-Fi access point and have access. So how did we structure the web interface? First of all, it's the same web interface for all Allegros. You don't have to learn new things if you switch from a small Allegro to a very big Allegro. Number two, we have split the Allegro in two different dimensions. Number one is the OSI layer, which means you can see here statistics on layer 2, layer 3, layer 4, and layer 7. On the other hand, we have a timing layer where you can easily zoom in and out of specific time intervals. So let's see what was the last hour. And here you can see real-time data. Here we see we are connected right now in inline mode. So this PC right now is behind this interface, and this webcast is running over these two interfaces. What I can do now is, for example, in the live mode, I can see what's happening right now on the link. So let me give you a very simple use case. If I'm opening a web page, how can I search for that in the Allegro? And here we get an overview of all IP addresses that I've accessed. So right now I've accessed, for example, the GoToMeeting server. Let me search here for example, for Facebook. Well, no, let's take CNN.com. So we don't see any correlation to CNN.com. But what will happen if I open now the tab CNN.com? It's loading, and we can see in parallel, in real time, what's happening with CNN.com. And right now I've sorted this by number of bytes, and I can easily click now on the IP address to see who did that. For example, here I look for the peers of it, and I see, oh, the MacBook Pro from Klaus has accessed this IP address. So now I can use this timing layer just to, for example, select this time frame. Now I'm not in live mode anymore. I'm in the timing mode, which means show me all statistics only from the time interval. And then you will find everywhere in the Allegro this PCAP button. If I press, for example, now this PCAP button, I can extract the traffic between this IP address from CNN.com and my computer back in time, and I simply get this as a browser download. And now I can open it with Wireshark. Hopefully my Wireshark will work. Yes, here we are. And here I see all packets from my request. The next thing I can do here is I can see on the dashboard, for example, what happened at which time. So if I zoom out now, we will see, very simple, a traffic peak where we have seen, 6.7 megabit. A typical troubleshooting case is something did not work. For example, you get a call this morning, I could not access this Windows file sharing server. I could not have a VoIP telephone, or the quality was bad. First question is, what happened at that time? So you can easily zoom out. Then, for example, here, if I see a traffic peak now, I can just zoom into that time interval, and I see, okay, I got a lot of traffic from data CNN.com, edition CNN.com, and so on. So this gives you a very quick overview what happened in the network. The correlation of the IP address and names is done in real time in the Allegro, because we analyze all the traffic up to layer 7. I would like to show you now a few features that are very interesting in many use cases. So for example, on layer 2, well, we can dig into what MAC addresses are there. But what is also very interesting here is if you have VLANs, you see single tag, double tagged VLANs, what happens there. So let's go back to live mode to see right now which MAC address has how much traffic. But on the other hand, we can also look into bursts. So did we see traffic at certain time, traffic which had some kind of burst? Well, right now we didn't have any burst. What is a burst? Well, if you see a highway, and I'll tell you, this highway has on average 10% load, it's something which is not interesting for you. The interesting part for you is at which time was the highway fully loaded. And this is what we can do with the burst feature. We measure every millisecond what's the load of the cable, and then display you 10% of the time this link was fully loaded, because there's a big difference between having on average 100 megabit traffic or having peaks where the link is full. Link full means the switch, the routers will fill their buffer and then will drop packets. Then it's very important to see who caused the burst. So very good statistics on layer 2. On layer 3, we have seen IP statistics. This is very extensive. So there are a lot of information below these IP addresses. But also, which is also very important, is quality of service, which means we debug here. We have also this feature for layer 2, but for layer 3, we debug who has used which quality of service, what's the flag name? The DSCP flag. And getting back here, this is very helpful if the network is splitted in specific quality of service classes. You can control who has used the telephony class, for example, and who has not used it. So this gives a very quick overview. And just imagine you use this solution on a central switch or router where you see thousands of clients and you can see immediately who's on the wrong quality of service class, which internal traffic causes the network to be overloaded because you only have right now monitoring on the parameter side. Okay. Again, on layer 4 transports, we have a lot of statistics for TCP. So for example, handshake times. So how long did a server to respond to a SYN on average? But you can also search for certain servers. Again, for the client, we have the same. You can look into retransmissions. So when did we have retransmissions? How much was it per IP? And as you measure in the middle, you can see, was it a problem on the left or on the right side? Then, for example, we have TCP flags. So which flag has been sent at which time gives you a very good overview if services are not used, if there's a downtime and you see a lot of reset flags, for example, at a specific time. And here again, we can search for who has sent most, who has received most reset flags, and also TCP 0 window. Oh, wait, none up to now. This is very helpful because 0 window means the client has sent a lot of data and the server did not update his window because he might be too slow. So that's a classical use case if you have a Windows file sharing server and the disks are just too slow. Or it's a problem of the window size, if the window size is too small. We can show that, and we often see correlations between an overloaded server and a lot of 0 windows. So a very good indication for overload. On transport side, we also have statistics, which port has been used. So if you now see, oh, who has used, for example, port HTTPS? Yes, we can see here that it is me. I'm accessing right now this Allegro over HTTPS, but it's also the GoToMeeting channel and some CNN data. This is very helpful, especially in closed environments where you know, okay, we should have only these 5 ports working. So in a hospital, for example, or a production plant. This helps you easily figure out which services are used internally, where you don't have any routers or firewalls in between. Okay. On application side, we have also, again, a lot of statistics, very basic, a detection of protocols, where we see that most of the traffic right now is SSL. Some parts are unknown. This is the audio sharing of the GoToMeeting in this case. But here we can also define our own configuration and specify our own protocols. Then we have a lot of special applications or decoding modules, for example, for HTTP or SSL or Windows file sharing. Let me just show you the SSL statistics, for example, where we can see the response times. So which server took how long to respond to requests? And for example, the most used server is from Apple, took between 27 and 31 milliseconds to respond. And so this was a good average time. So this is available for many other services on HTTP. One very interesting feature I can show you is SIP statistics. Why? Here we can debug phone calls, and I can do that in real time here. So just let me do a call, and we can see in real time now here on top this call, and see here, let me zoom in. And we see here now in real time the data rate. So what is the caller, callee packet rate, how is the MOS, do we have big jitter, and so on. So just stop the call. And this gives you a very easy way. Now let's zoom into that call. And now, once the call is over, we can see this call and zoom in. We can extract the zip traffic, the zip plus RTP traffic. We can search for that call, for example, here. So if you have millions of calls and you get a request that, oh, this call was not good in quality, you can look into it. Was it a problem on network side? Was it a problem on the server side? Was it a problem which is not yours? So it's on the cloud provider side. Okay, so this was a very quick walkthrough of a few of the features of the Allegro. Just at the end, the Allegro itself uses an in-memory database, which means we store all statistics for a certain amount of time. The more connections, the more IP addresses we see, the less data we can, the less time we can store. We show that in the Allegro web interface. So right now, I've just started the box. It tells me, hey, with this traffic all day and night, I could store roughly 1 day and 7 hours, but this will grow a lot. So this unit, if I use it only on my PC, it will hold all information for the last at least 4 weeks, for example. And bigger solutions have more in-memory database, which can store a lot more. We have customers who have roughly 40,000 client PCs behind one Allegro, and they use one Allegro to debug the whole network. On the other hand, we have the packet ring buffer, which is here on a storage. In this case, it's a USB SSD, and this stores just all packets that are going through the Allegro. And for example, if for data protection, or if we have a 10 gig link, but we are using only a small disk and we can't store 10 gig, we can add easily here snapshot rules, which means, for example, let's only store all traffic from that IP subnet. And for that subnet, we store, for example, the full packet, rule 1. And rule 2 means all packets discard, which means right now, only this subnet will be captured and the rest is discarded. By this case, you can investigate network traffic from layer 2 to layer 7, but do the PCAP storage only for a very small part. Here, a good example is again VoIP. You can look at the whole traffic, see who's causing bursts, everything, but you can investigate the voice traffic. Thank you very much. This was a very small walkthrough of the Allegro. I would be happy if you have questions to answer now questions.
The only question right now I have is, does this device has Wi-Fi? Because I read on your webpage that it should have somewhere.
It has Wi-Fi for management. Network ports that analyze the traffic and the management is completely split. So there are ports which are used for debugging traffic, and there are ports who are used for the management interface. And the Wi-Fi is for management only. So we do not debug a Wi-Fi in this case. This is
okay.
So if you would like to debug a Wi-Fi, we strongly recommend install the Allegro between the Wi-Fi access point and the network.
And when did you start with Allegro Packets?
We started, so we funded the company in 2014.
Do you have any use cases right now?
We have a lot of use cases. So we have a few use cases on our webpage. They will follow a lot more. Well, one success story or one large use case, what we have done is with Arvato Systems in Leipzig. And for example, they monitor a lot of data centers with, well, they have a few large units of the Allegro. And there we have found a lot of bugs which they have in network setup. And we even discovered a bug on a Cisco switch that was critical on the management side that could take down the port of the Cisco switch. We have use cases there. Our classic use cases are you don't know what's going on in a network, or you hear about an issue and but you don't know where to start. So one nice use case here is we have been in a production plant, and this was car manufacturing, and they had the big problems that their KUKA robots stopped working after everyone stopped working for about half an hour once per week or twice per week, but it was random. They didn't know why, and it only showed a message network error, and they couldn't figure out where's the network error. They switched a lot of components, everything, and at the end it was a problem of spanning tree in the data center. For some reasons in the data center, a spanning tree link was not stable, and so the link was down for 30 seconds and the robots had a timeout of 20 seconds. So if these two things come together at almost the same time, then the robot reported network error. So that was a use case where they debugged without the Allegro about 9 months. And with the Allegro, it took them only 1 day to figure out what's the problem, that the data center is not responding anymore. And before that, they tried to record a PCAP of 1 or 2 or 3 robots for a week and hope that it happens in this time. And then they had 50 gigabytes of PCAPs and couldn't use it.
Okay, and let's say if I buy a device from you, will be able to help me with, because let's say I'm not engineer and I don't know how to read the pickup data. Could you help me with that or not?
Yes, of course, we can help you. Our experience is that many network administrators can work very easily with the Allegro if they have basic knowledge. So what is a MAC address? What is an IP address? What does DNS mean? What does HTTP mean? But of course, on top, we are here to support and to understand the web interface. So there's also an integrated manual where we describe use cases, how to use that, which is in the Allegro, which is integrated and which can describe a lot of features and how to use and how to set up specific things. So, and we are here to help, of course. That's why we also have support directly from Germany, and we also help with debugging. If it gets too much, so if it's a larger project, we offer professional services on top, which we can do remotely or even on site.
Okay, then thank you very much, Klaus, for your time and for this presentation. And we'll see you next time, I guess.
Okay, great.